Hi there. For this video, we'll be solving absolute value equations wherein this time we have two absolute values in our equation. So this type of problem is a bit more complex, but I'll try my best to explain it and how it works. So let's have this example. Let's have the absolute value of 2x plus 3 plus the absolute value of x equals 4. So as you can see, we have two absolute values here. And to solve this, we must first introduce the idea of critical points. So essentially, critical points are values of x that would make the value inside our absolute values be 0. So there's more into that, but we'll try to take it step by step. So let's first get that one. So we have 2x plus 3 equals 0. Move the 3 on the right side to obtain 2x equals negative 3. Divide to both sides and we obtain x equals negative 3 over 2. Next, we have x equals 0. For x equals 0, that's it already, since we don't really need to manipulate it anymore. So our two critical points in this case are x equals negative 3 over 2 and x equals 0. Now, what does this two values of x mean or signify? Well, if we move over here, and let's first focus on the absolute value of 2x plus 3. Note that the absolute value of 2x plus 3 is actually equal to, it can be equal to 3 versions. So we've got here negative times 2x plus 3. We've got here 0, and we've got 2x plus 3. So again, recall that the critical points are the value of x that would make this expression inside the absolute value 0. So we know that the absolute value of 2x plus 3 is equal to 0 at x equals negative 3 over 2. How about this part? Why is there a negative out here? Well, this part out here represents the value of absolute value of 2x plus 3 for values of x that are less than the critical point, which is negative 3 over 2. So let's remove this one. And move this one out here. So why does this out here happens? Well, let's try to have an example. Let's take a point in this interval out here. So a value of x that is less than negative 3 over 2 can be x equals negative 2. Observe that if we get x equals negative 2, or the value of 2x plus 3 at x equals negative 2 will have 2 times negative 2 plus 3, which is negative 4 plus 3, or simply negative 1. And since we're dealing with absolute value out here, we must take its positive version. So how do we do that? Well, we can multiply this by negative 1 to obtain the positive version, which is 1. So this multiplication of negative out here is where this negative sign occur. How about for this region out here? Well, this is just the ordinary or the typical region, wherein this one out here is simply, or by that I mean if we get a positive value out here, we simply note that the absolute value of this one is simply the expression inside, or the 2x plus 3. So this happens for cases where x is greater than the critical point, which is negative 3 over 2. So as an example again, if we take a value that is greater than negative 3 over 2, we can take x equals 0, and then note that at x equals 0, 2x plus 3 is equal to 2 times 0 plus 3, or simply 3, which is positive. So this is already the absolute value. So that is how critical points work. For the next one, for x equals 0, let's move it out here. We simply have the absolute value of x is equal to 0, negative x, and x. For at x equals 0, at x less than negative, at x less than 0, and at x greater than 0. So you can try out some test values out here at x less than 0 and x greater than 0, and you will see that this is indeed the absolute value representation of those values at x, at a certain x. So now, what is the importance of this? Well, we now create a number line out here. So let's first resize this one. And this one here. Save some space. You can also move this one out here. And there, just to keep things organized. So creating our number line, we have here a line. And then we plot our critical points, which is at 0 and at negative 3 over 2. So note that this critical points actually divides our number line out here. And as you can see, we have 3 parts out here. This one, and this one. And this parts out here will actually be our cases. So we have here case 1, case 2, and case 3. So this is now the time that we can solve our absolute value equation. So again, going back, this one out here is our absolute value equation. So let's copy this one and bring it down around here. So let's start with our first case. So at case 1, we have x is less than negative 3 over 2. So it's over here, this region. So at x less than negative 3 over 2, note that 2x plus 3 will become this one. So we will have here negative 2x plus 3 for x this will be, note that if x is less than -3/2, it's also less than 0. So at x less than 0, we got this case out here. There. So this will be -x. So now, our equation will become -2x plus 3 equals, plus -x equals 4. Then, we can now solve this since this is just a linear equation. So we first distribute the negative sign out here to obtain -2x minus 3 minus x equals 4. Combine the like terms, we obtain -3x, and we can move the -3 out here to the right side of the equation to obtain 4 plus 3 or 7, which this simply simplifies to x equals 7/3, that is negative. So this is our first value. First possible value, to be specific, since we will be still checking these values to make sure that it is valid in this equation. Let's go on to our case 2. For case 2, we have let's call it out here, this region out here. So that will be from -3/2 to 0. So we have here x is between -3/2 and 0. So at this region, or at this interval, 2x plus 3 is now served at this one. X is greater than -3/2. So it is 2x, the absolute value of 2x plus 3 will become this one. So this will be 2x plus 3, and for the absolute value of x, since it is still less than 0, so just similar to the first case, this will become -x. And now we can solve our equation. So we have 2x plus 3 plus -x equals 4. Combining the like terms, we'll have here x, and move 3 to the right side of the equation, and we obtain 4 minus 3 or 1. So we have here x equals 1. For our third case, case 3. For case 3, it will be this region or interval out here. So that interval is at x is greater than 0. So at x is greater than 0, we've got 2x plus 3 to be, note that at x greater than 0, this also implies that x is greater than -3/2. So it's the same in case 2, which means that we have here 2x plus 3. For the absolute value of x, for x greater than 0, note that that will be this one out here. So we have here x. And now let's solve this equation. So we have 2x plus 3 plus x equals 4. Simplifying or combining the like terms on the left side of the equation, we'll have 3x, and then moving this 3 on the right side of the equation will have 4 minus 3, or simply 1. Now dividing 3 both sides, we'll obtain x equals 1 over 3. So now so far we have 3 values of x. We've got here x equals negative 7 over 3, then x equals 1 out here for the second case, and we have x equals 1 over 3. The last step is to check these values. So let's go here at the first case. Observe that at x equals negative 7 over 3, our absolute value equation, which is this one out here, will be the absolute value of 2 times negative 7 over 3 plus 3 plus negative 7 over 3. This one will be equal to, on the left side, we'll have negative 14 over 3 plus 3 can be written as 9 over 3. And on the right side, that will simply be 7 over 3. The left side of the equation, negative 14 over 3 plus 9 over 3 will be negative 5 over 3. So this, getting the absolute value of this one, will have 5 over 3, then plus 7 over 3, or 12 over 3, or simply 4. So it's correct, since we got this one. So this one out here is a solution to our problem. For case 2, let's do this. We'll have here 2 times 1 plus 3 plus the absolute value of 1. And yep, this one will be equal to absolute value of 5 plus 1, or 5 plus 1, which is 6, which is not equal to 4. So this solution out here is wrong, or not valid in our equation. Last case. For this one, we've got the absolute value of 2 times 1 over 3 plus 3 plus the absolute value of 1 over 3. And there. Simplifying this, we'll obtain, on the left side, we've got 2 over 3 plus 3 can be written as 9 over 3 plus 1 over 3. On the left side, this simplifies to 11 over 3. And on the right side, we've got 1 over 3. When added, we'll have 12 over 3, which is simply 4. So it's correct. So x equals 1 over 3 is a valid solution to this problem. And so we are done. But if you are wondering, since in our cases, here in case 1, case 2, and case 3, we don't have, here in case 1, case 2, case 3, we didn't include x equals negative 3 over 2 and x equals 0. But that can be easily verified that at x equals negative 3 over 2 and x equals 0, the outcome will not be equal to 4. So you can verify that one. Verify that at x equals negative 3 over 2 and x equals 0, equation is not satisfied. So with that, we can now conclude this problem out here. So we can conclude that the solutions of the equation are x equals negative 7 over 3 out here, let's use a thinner pen, x equals negative 7 over 3 and 1/3 out here. Oops. So yeah, it's quite a lengthy problem, but you can try this for yourself, and as time passes by, you'll get more used to how to solve this without even needing to do this part out here. This one, without even needing to do this part, you'll simply immediately know what cases are needed to solve that certain equation. So to end this one, here's an exercise that you can work on. So you can try out the absolute value of y plus 5 plus the absolute value of y equals 8. So you will use the same idea from the example that we had in this video. So that's it. It's quite a lengthy video, and it kinda got messy in the solving process, but I will make sure to put in the timestamps in this video for your guide in skipping through the solution or certain parts of the video, depending on your own preference. So that's it. Feel free to comment down below your answers and solution to this exercise, and if you want to try again the example in this video. So that's it, and that's all for this video.